Here is our agenda for today. Our quote of the day is, "He who asks a question is a fool for 5 minutes. He who does not ask a question remains a fool forever." Confucius. Our agenda today is I can graph linear equations on the coordinate plane. So our first thing that we always do when we start a lesson, I'd love for you to please click on Joey and tell him how you doing today. All right, so click on Joey, fill out that form for me, and you're going to come back when you're ready to start our note packet. So here are our notes for today. It's lesson 3.1, graphing linear equations. And we're going to look first at slope-intercept form. Now, right here you see slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. When I graph a line, it is graphed by plotting a point on my y-axis first, and then I plot slope, and then from there I can plot using the slope as its rise over its run. So we're going to do some examples right here. We're going to also write the equation of these lines in slope-intercept form and graph our line. So looking at this, first off, I'm going to go back to my equation of a line. My equation is y equals mx plus b. And I'm going to substitute in. M is 4, b is -2. So when I rewrite my equation, it's just y equals 4x plus -2. Or I don't need to write a plus -2. I can just write 4x minus 2. Now on this graph below, we're going to graph it using our slope and y-intercept. So I start always with my y-intercept. Here's my y-intercept at -2. So I'm going to plot a point on my y-axis, which is my vertical axis, at -2. And then I'm going to move using my slope. If my slope is 4, that's the same as 4 over 1. So that is my rise over my run. So starting at -2, I'm going to rise or go up 4. 1, 2, 3, 4. And then I'm going to go over to the right 1. Then I'm going to continue that pattern. Up 1, 2, 3, 4, over 1 to the right, and up 1, 2, 3, 4 to the right 1. Now I can plot that line. And when I plot my line, I'm going to need to fix it a little bit so it goes through my points. Here we go. Make sure that we always draw arrows at the end of our line. And I like to label my line y equals 4x minus 2. All right, we're going to try the second one. The second one has a slope of -2 over 3, and my b is 0. So I'm going to rewrite my equation, y equals mx plus b, and I'm going to substitute in y equals -2/3 x, and then plus 0. I don't need to write plus 0 because if I add nothing to it, nothing's going to change with my equation, so I can write y equals -2/3 x. From here, I can plot again, starting with my y-intercept, or that b. B is where you begin. You begin at 0 on your y-axis. That's at the origin. Then our movement is -2/3, or our rise is -2 and our run is 3. So instead of rising 2, because it's a negative, I'm going to fall or go down 2, but I'm still always going to go to the right 3. So go down 2/3 to plot your next point, down 2/3 to plot the next point. And again, I can connect these with a straight line. If you were doing this on paper, you would use a ruler. And then lastly, label with our equation of our line. The last equation that we have here, our m is 0 and our b is 4. So I want you to substitute in when you substitute, you'll get 0x plus 4. 0x, anything times 0 is 0. So I can just write y equals 4. But in order to plot, I do still want to go back to this. I'm always going to begin, again, at 4 on my y-axis. So I'm drawing a point at 4. My rise and my run are 0. Now, what does that look like? What does a 0 slope look like? A 0 slope is a horizontal line. And this is the case because if y equals 4, everywhere that you go across this line, your y coordinate would be 4. Any point that you picked. If I picked this point, this is the point 6, 4. If I pick a point over here, this is the point -8, 4, right? No matter what, y equals 4. That y coordinate is 4. So you can draw your line. Another way to draw your line is to put all of these equations into your graphing calculator into y equals and hitting second graph to look at your table. As we go down, I'm going to try that for number 4. So in my calculator, I would type in to y equals -3x plus 5. Then I'm going to hit second and graph to look at the table. When I look at my table of values, the numbers that I like to look at in my table always start at -2, -1, 0, 1, and 2 because I like to get some before my where x is negative and some where x is positive to draw my line. So when I look at my table, well, I'm gonna graph this. Okay, so when I graph this, if I were to graph it using slope-intercept, I'm gonna pause my table for a second. If I were to graph this using slope-intercept, I would begin at +5, and I would go down 3. This is the same as -3/1. So that's my rise over my run. That's my M. So I'm going to go down 3 over 1, down 3 over 1. And once I have a bunch of points plotted, I can connect them with a line. I think I have 1 point off right there. I mismarked my point. I only counted up to 1, 2, 3 over 1. Here we go. All right, so now when I draw my line, it should look more like a straight line this time because my slope's correct. But we're always going to make sure that we draw an arrow at the end of each side of my line. All right. So now if I were to graph this, I would have negative, or if you were going to look at your tape, this is what you would do if you were graphing it with a normal slope intercept. If you were going to graph it looking at your table, you would get -2, +11, -1, 8, 0, 5, 1, 2, and 2, -1. And all of those points exist on that line. Looking at this next problem, I don't have this in y equals, so I'm going to have to manipulate my equation to move it into y equals form. To get this y by itself, I'm going to divide everything by the coefficient. So in this case, the coefficient is -2 because it's the number in front of my y. So I'm going to need to divide each part by -2. We're going to divide by our coefficient to get y by itself. So now when I divide, I get y equals, which is exactly what I was looking for. And now I'm going to say 6 divided by -2 is -3x. And then -8 divided by -2 is a +4. So now I'm going to identify my slope and my y-intercept. So my slope, the m in my y equals mx plus b, is -3, which is the same as -3 over 1. And my b, or my y-intercept, is +4. So I'm going to begin at +4. And my m is how I move. That's my rise over run. I'm going to go down 3 and over 1. Down 3 over 1. 3 over 1. And once I have at least, I would say, 4 points plotted, I can draw my line. And arrows go at the ends of my line. Oh no. Arrow, arrow. All right, we have one more. Looking at our equation for this one looks nothing like the others. But as always, we're going to try to get y by itself. So in order to get y by itself, we're going to need to do a couple things. Guys, think back to literal equations. When we go get y by itself, we're going to need to first get this 2x to move away from it. So we're going to move the 2x to the other side of my equal sign. You get 3y is equal to, and I always like to write my x's first so that it's already in my nice form for me, because I want it to look like y equals mx plus b at the end. So now I still don't have y by itself. I need to move that 3. So to move the 3, I'm going to divide by the coefficient. Y equals, and over here we're just going to write negative 2/3 x, and then minus 4. Now you might be asking me, why do we leave this as negative 2/3 instead of dividing it in my calculator? If I divide that in my calculator, I get negative 0.6 repeating. That is not useful to me when I go to graph. But you know what is useful to me? Is if this is a fraction. Because now, when I go to write my m, it's already as a fraction, and it's easy for me to determine my rise and my run. So I'm going to begin at 4 on my y-axis, and I'm going to move by going down 2 and to the right 3. Down 2, right 3, down 2, right 3. And again, we connect them with a line. Notice that my line also extends all the way off my graph, or it will in a second, once I fix it. Here we go. My line extends all the way off my graph. Oh no. It wasn't the right color anyway. We'll fix that. And make sure that you have arrows at the end. If you have a very small graph here, we will not, it won't be pretty, no. It looks nicer, and we can tell what's going on when the line is extended all the way across. The other thing that I do want to note right now is that when you go to label your line, to make sure that you label it with the original equation that's given to you. So in this case, it was in standard form. So I would just rewrite it exactly how I see it right there on the line. Looking back to your agenda, you have a couple activities to do. You have a marble slide activity on Desmos. And once you've completed the marble slide activity, you're going to do practice 3.1 on Delta Math. All right, guys, I will see you next lesson.